A survey of 150 people's eye color was taken with the following results. If one person is chosen at random, what's the probability that the person is a female? Well, we just need to take the number of females in the chart, which is 80, and divide that by the total number of people altogether, which is 150. So 80 over 150, 0.5333 when we round to 4 decimals. Okay, part B. Is a male and has brown eyes. Well, the word "and" generally is telling us to multiply two probabilities together, but from a contingency table, it's like the multiplication's already done. All we have to do is just look to how many events are in the intersection of these two. So here's the males, here's those with brown eyes. So they intersect at the number 41. That's the number of males that have brown eyes. And then there's 150 in our sample altogether. So 41 over 150, 0.2733. Part C, does not have green eyes. Well, there's a couple of ways we could do this. If someone does not have green eyes, then the only other possibilities from this data is brown or blue. So we could add 60 and 71 together, and that would give us the result. Another possibility is to take 1 minus 19 over 150, and the 19 over 150 is the probability that someone does have green eyes. And since all the probabilities have to add up to 1, if we take 1 minus the probability that someone does have green eyes, that'll tell us the probability that they do not have green eyes. I'll show you. So you get 0.8733 this way, or if you take 60 plus 71 divided by 150, you're also going to get 0.8733. Doesn't make any difference which way you go about it. Part D, what's the probability that a person has blue eyes or is a male? Now, the or probabilities can be tricky. You have to first decide if it's possible that these things could happen together. If it could, you have to subtract out the intersection. So it is entirely possible that a male has blue eyes. So we have to consider the intersection. So what we're going to do is find the number of males that we have. So there's 70. Then we're going to add to that the number of people that have blue eyes. So there's 60 there. But the thing is, when I come up with the 70, I'm adding 25 plus 41 plus 4. And when I come up with the 60, I'm adding 25 plus 35 plus 60. I'm sorry, 25 plus 35, which gives me 60. So I'm adding this 25 into that calculation twice, so I have to subtract it out once. And if you'll notice, that's the value that's in the intersection between male and blue eyes. So it's always add their respective totals and subtract the intersection. So 70 plus 60 minus 25 divided by 150 gives us 0.7. Part E, find the probability that someone has green or brown eyes. Well, it's not going to be possible for somebody to have both here, at least not within our chart. We're always considering these contingency tables to where, a person has blue, has brown, or has green, and there's no, overlap. So since there's no overlap between those who have green or brown eyes, all we have to do is just add their respective numbers. So green, there's 19. Brown eyes, there are 71 that have brown eyes, a total of 90, and then that's out of the 150 total. So we have 0.6. Part F, what's the probability that a person has green eyes given he's a male? Well, for the given probabilities, the thing you kind of have to just make sure you restrict yourselves to is just one part of the table. So we're given that this person is a male. Then all we're going to look at in this table are the males. So I'm just going to circle the males here, and I'm going to restrict myself to just these numbers. So we know the person here is a male. What's the probability now that they have green eyes? Well, there's 4 males with green eyes and 70 males altogether. So the probability here is 4 over 70. So that probability is 0.0571 when rounded to 4 decimals. Okay, part G. What's the probability this person is a male given he has brown eyes? So the difference here is now we know that the person has brown eyes, so we're going to restrict ourselves to just the people with brown eyes on the table. Now, from the people with brown eyes, what's the probability that the person is a male? Well, there's 41 males with brown eyes out of 71 people with brown eyes altogether. So it's going to be 41 over 71. So 0.5775. You've got to be very careful when doing these given probabilities and make sure you get the denominator correct. Almost everybody gets the numerator just fine, but it's the denominator that usually causes problems. So make sure you know, and I always just recommend circle the part of the table that you're working with, and then that way you're kind of restricting yourself to just one part of the table, then find your probability. I think that's the way of saving yourself from making a small mistake. All right, part H. What's the probability that a person has brown eyes given she's a female? Well, since we know this person is a female, I'm going to start off by, just restricting myself to that part of the table and just circling it. Okay, so just restricting myself to the females here. Now, we know she's a female. What's the probability that she has brown eyes? Well, there's 30 females with brown eyes and 80 females altogether. So it's going to be 30 divided by 80, which is 0.375. If you'll notice, the only time that we had a denominator other than the total overall here, the 150, is when we have these given probabilities. All the other types of probabilities that we've done, the not, the ors, the ands, and just the general probability, all have 150 in their denominator. It's only when we have the given part that we have a restriction on our denominator. So just keep that in mind as you're working through the problems.